So good evening everyone and welcome to this lecture. We are into lecture number 7 in capacitance, and in today's lecture we are going to deal with series parallel combination. Up till now what we have done is that we have found out the charge and the potential difference or the potential of each conductor when they were in series or parallel. In the last class we dealt with how do you find the charge, potential, energy and everything when conductors are connected in series or in parallel. In the last class before that we had done the questions on how to find out the same thing in terms of series connection. Do we remember it, everyone? Yes or no?
Sir,
Okay, so what we are going to do in today's class is we are already done the questions where we were supposed to find out. We were supposed to find out the values of charges and energies. In today's class, what we are going to do is we are going to solve questions where we have to find out the equivalent capacitance. Equivalent capacitance, and we will be dealing with questions where what, where the capacitance will not be purely in parallel or purely in series. There could be some capacitors which are in parallel, there could be some capacitors which are in series, and then we will have to find out the equivalent resistance, no, not resistance, equivalent capacitance between the two given points. Okay, do we understand what we are supposed to do in today's class? We'll have to find out the equivalent capacitance. So we will try to concentrate on the questions where we have to find out the equivalent capacitance between 2 points. Now, how do we find out the equivalent capacitance? This is a question taken from a very famous book. I hope you have heard the name of the book, S.C. Verma. This is a question taken from S.C. Verma. And here we have to find out the equivalent capacitance between point P and N. You can see this is the point P and this is the point N. Now, how do you find out the equivalent capacitance between the point P and N? You can see there are three capacitors connected over there. I can't see you today, so I don't know whether everyone is there or not. I hope everyone is good. There are three capacitors here. Now, how do you find out the equivalent capacitance between point P and point N? Anyone can tell me? No one? How will I find out the equivalent capacitance between P and N, the 2 points P and N? Yes? Am I audible and visible to all of you? Sir, add 10 and 20. Why do I add 10 and 20, Abhidham? Why do I add 10 and 20? Why do I add 10 and 20? Because this 10 and 20, if you look at this 10 and 20, they are in parallel. That is correct. This 10 and 20 capacitors are in parallel. First, we can understand that these are in parallel. So what we can do is, in place of these two capacitors, we can put one capacitor whose capacitance would be equal to 20 plus 10, that is 30 microfarads. If I do that, then if I draw the circuit between points P and N will look like this. This is the 30 microfarad capacitor which I have created because of the parallel connection. Do we understand this?
yes, sir.
and this is the original capacitor of 30 microfarad, which was originally there. And then the question becomes pretty straightforward, pretty simple. Now this 30 and 30 capacitors are in series. Now you can tell me the answer of this effective capacitance. What is the effective capacitance between P and N? Yes, 30 and 30 in parallel, 30 and 30 in series, two equal capacitors in series, it will be 30 divided by 2. So my final answer will be 15 microfarad. So 15 microfarad should be the equivalent capacitance between point P and N. Do we understand this? Yes or no?
Yes, sir.
This is how you must solve any question that comes on this category. Can I move on? Has everyone understood this? Has everyone noted this down? Yes or no? Okay, I'll give you 2 minutes. Note it down. Let me know once you are done. This is problem number 2. You have to find the equivalent capacitance between A and B. A and B, you have to find the equivalent capacitance. Take your time. Do it patiently, slowly in the beginning. Once you understand how to do it, you can do it faster also. Take your time. I'll give you 2-3 minutes, but please do it. So, how I'm supposed to do this, beta? You can see here this 12 and 6 capacitor, they are in series, same charge will flow through them. So I can find out the equivalent capacitance of this combination. How can I find the equivalent capacitance? It will be C1 C2 12 into 6 divided by C1 plus C2 12 plus 6. So I think from here you will get 4 as the answer. As soon as you get 4 as the answer, you can redraw the circuit in your mind. In your mind, you can see on the top there is a 4 microfarad. In the second branch, you have 2 microfarad. This is point A and this is point B. This is 4 microfarad. This is 2 microfarad. So my answer has to be, now this 4 and 2, everyone can see they are in parallel. The answer will be 4 plus 2, and hence the answer should be 6 microfarad. 6 microfarad is the answer that we are looking at. Do we understand this? Yes or no? No or yes?
Yes, sir.
Did anyone got the answer, sir? No one got the answer? Not a good sign. No one got the answer apart from Abhiram?
Got it, sir.
And why you're not speaking, sir? You take so much of time to speak, beta. Will not be able to do more questions. Anyways, here comes the next one for you guys. Question number 3 on this category. You have to find out the effective capacitance between point P and Q, and I will give you 2 minutes. And I hope that I get answers from everyone. Your 2 minutes starts now. So, how are we supposed to solve this question? Can anyone tell me? You can see here straight away, you can see this 4 and this 4, they are in parallel. So 4 plus 4. So what you can do is you can cut them out, take them out, and in place of 4 plus 4, you can put one capacitor of 8 microfarad. And then if you look at the circuit, these three, 8, let me use a different color. These three capacitors 4, 8 and 4 are in series. You just have to find out the effective capacitance. How you can find effective capacitance? 1 by C equivalent will be equal to 1 by 4 plus 1 by 4 plus 1 by 8. The and you will get the answer, and then whatever you get you will have to inverse it. So from that I think you will get C equivalent as 8 by 5. This is one way of doing it. The other way, if you want to reduce the calculations, what you can do is you see here that there is a 4 and 4. All these three are in series. 4 and 4 are also in series. So you can first add 4 and 4. If you add 4 and 4 in series, it will become 2. They are equal, divided by 2. So it will become 2. Then this in place of this 4 and 4, you can put 2, and then this 2 and this 8 will be in series. So you can find the equivalent capacitor as 2 multiplied by 8 divided by 2 plus 8. This way also you will get the same result. So I will now leave it to you to decide which is the simpler way, which way you want to solve the question. No matter how you do it, you take three of them in series, it is correct. You can take first two of them in series, add them for simplified answer, and then take the other two in series. Do we understand this? Yes or no? No or yes?
Yes, sir.
So anyways, you can do it better. It does not make any difference. The end result is always going to be same. Can we move on to the next question, bacha? Can we move on to the next question? Is everyone able to understand what type of questions are coming these days?
Yes, sir.
Okay, this is the next one, my dear friends, and I hope I can get the answer quickly. I will show you the entire question. So now tell me, what is the answer for this one, bacha? Simple question. Simple question. The question is coming on your screens now. Question number 4, I think, or 5, I don't know. In the circuit diagram shown in the adjoining figure, the resultant capacitance between P and Q is. P and Q are the points. You have to give me the resultant capacitance. I'll give you 2 minutes to solve it. Best of luck. I know you can give me the answer. Try it. Option B is the correct option, my dear friends. 3 microfarads is the eventual answer. How are you supposed to do this? As soon as you see this question, beta, you see that these 2 and this 3 is in parallel. Both plates are, one plate is connected to the one point and other plates are connected to the other point. So basically these two are in parallel. So now you can add, now you can remove this entire thing and just add a capacitor which is equal to 5 microfarad. 2 plus 3 is 5. Then you can see this 12, 5, this 12, 5 and this 20. All these three capacitors are now in series. So you can do it by this formula. 1 by C equivalent will be equal to 1 by C1 plus 1 by C2 plus 1 by C3, or if you can just use the shortcut, what you can do here is you have this 5 microfarad and this is 20 microfarad. You can first find between 5 and 25 what is the equivalent capacitance. Between 5 and 25 what is the equivalent capacitance. So it will be between 5 and 25 what is the equivalent capacitance. It will be 20 into 5 divided by 20 plus 5. So that is 100 divided by 25. So that is 4. So once I get the value of this as 4, then this 4 and this 12 are in series. Then you can find out between this 4 and this 12. How you can find out between this 4 and this 12? You can do 12 into 4. divided by 12 plus 4, and this way you can get your answer as 3, or you can do it 1 by 12 plus 1 by 5 plus 1 by 20. Doesn't matter, beta. You will always end up with the same answer. Do we understand this? Yes or no? No or yes?
Yes, sir.
So you can do it in any way that you wish. Ultimately, your answer is going to come same no matter how you do this. Shall we move ahead with other questions? The more the number of questions that you are going to solve in this case, the better you are going to be. Can you move on to the next question, bacha?
Yes, sir.
This is again a question taken from SCV, and I hope you can give me the answer for this one. The equivalent capacitor of the combination. So from where to where it is not given. So you can take this point as A and this point as B. You have to find out the equivalent capacitance between A and B, and I'll give you 2 minutes to do that. So how are we going to do this? This looks like a different question.
Option
Now,
B.
option B is correct. 2C is correct. How did you get it? Now, beta, just look at this capacitor, this pink capacitor. You look at this point and you look at this point. Now, both of these points through which uh, this plate is connected to this point and the other plate is connected to this point. But these 2 points are actually connected to each other. So that basically means that the two plates of the capacitor are joined to each other. Now, in that case, what happens when the two plates of the capacitor are joined to each other? The potential difference becomes zero. And if the potential difference becomes zero because the two plates are joined, can you understand that the two plates are joined with each other? Do we understand this? There is no capacitor coming in between. The two plates of the capacitor are joined. So basically what happens, beta, no charge will come on this capacitor, and actually you can take this capacitor out. You can take this capacitor out of the circuit. Nothing will come here. So this becomes out. Now, if you look at A and B, you can straight away say that this C and this C are in parallel, and therefore your net capacitance becomes C plus C, that is 2 times C. So the answer is 2 times C. Do we understand this? Yes or no? No or yes?
Yes, sir.
So the answer is 2 times C, my dear friends. I hope everyone has understood this. Can you move on to the next one, bacha? Okay. Chalo. Then this is the next one. This C1 capacitor is 4 microfarad. Both the C1 capacitors are 4 microfarad and both the C2 capacitors are 6 microfarad. You have to find out the effective capacitance between A and B. I will give you 2 minutes to solve this. So how are you going to do this, my dear friends? How are we going to solve this problem? Well, you can see here between this point and this point, there is no capacitor connected. That means these 2 points are not different, but they are same. Now, if these 2 points are same, that means this capacitor C1 is actually connected to capacitor C2 like this. One end is connected with each other and the other end is also connected with this point A. That means your C1 and C2 capacitor will come in parallel. Do we understand this? One plate is connected to point A, and if I can call this point as point C, the other plate is connected to point C. Therefore, C1 and C2 come in parallel. Do we understand this? Yes or no?
Yes, sir.
Similarly, my dear friends, this C1 and this C2 also come in parallel with each other. Do we understand this? 4 plus 6 are in parallel. So 4 plus 6 is 10. What this 10 and this 10 are in series. 10 and 10 are in series. 10 and 10 are in series. The effective capacitance becomes 10 by 2. That is 5 microfarad. Do we understand this? Yes or no? No or yes?
Yes, sir.
So the final answer is 5 microfarad for this case. There is a cousin brother of this problem, and all of these problems I'm taking from SCV. As you can see, it is quite simple. This is the next problem, and if you have understood the previous problem, this problem, and that is why I'm putting it side by side of the previous problem. Here also C1 is 4 microfarad and C2 is 2 microfarad, 6 microfarad. Can you tell me the effective capacitance between point A and B? I wait and I wait. Shall I wait or shall I go ahead in life? Life has to move on. Huh? Okay, I'll give you time, 2 minutes. What about the others? This is exactly same, beta. This C1, which is 4, and this C2, they are in parallel. So this becomes 10. Similarly, this C1 and this C2 are in parallel. Same concept. It becomes 10. This 10 and 10 are in series. So 10 and 10 in series, this becomes 5. Similar concept applies here. These two are in parallel 10. These two are in parallel 10. Then these two are in series 5. Now once you get 5 in the upper branch and once you get 5 in the lower branch, 5 in the upper, 5 in the lower, this is point A, this is point B. So 5 plus 5, 5 in the upper, 5 in the lower, 5 in the upper, 5 in the lower, 5 in the upper, 5 in the lower. The total capacitance becomes 10 microfarad. Do we understand this? Yes or no? No one understands this?
Yes, sir.
Anyone got the answer for this one, bacha? Or no, sir? You got the answer?
Got it, sir.
Then give me the answer for this one, sir. Each capacitor is 2 microfarad. Each of the capacitor is 2 microfarad. You have to tell me the capacitance between A and B. You have to tell me the capacitance between A and B. Each capacitor, my dear friends, is 2 microfarad. 9 by 2, Abhiram is telling me. 9 by 2. 9 by 2. Okay. Can I help you out with this? 2, sir. Yes, sir. This two, and this two, they are in series. These all three twos are in series. So you will get in this branch, the effective capacitance is 2 by 3. Similarly, these two, they are in series. The effective capacitance here in this branch is also 2 by 3. These three are in series. So the effective capacitance in this branch is also 2 by 3. Then all of these are in parallel. So 2 by 3 plus 2 by 3 plus 2 by 3. And my final answer will be how much? 2. 2 microfarads. Everyone understands this, or this has gone above it saying bye bye? Bye bye, I'm going. Don't worry about me. Huh? Bye bye. I'm not getting any response. I hope everything is good in the universe.
Yes.
Everything is okay in the universe. Not getting any response. I don't get any response. I get worried. Anyways, here comes the next one for you, my dear friends. I forgotten the question number. Let me just start with question number 11. What is the effective capacitance between A and B, my dear friends? Remember, the more the number of questions you do, the better you are going to be. Between A and B, remember the points, my dear friends. A is here, B is here, both hanging around. Yes, my dear friends. Remember, this A is the first point and this B is the second point. We have to find the capacitance between A and B. Anyone? I'll give you a minute, beta.
Sir.
Well, that is correct. The answer is 5. And how do you get it? Remember, the points A and B are down. So now you look up and you can see this 3 and this 6. They are in series, yes or no? The 6 and 3 are in series. So 6 and 3 are in series. 6 into 3 divided by 6 plus 3, 18 divided by 9. So what you have is, you can replace these two gentlemen. You can take them off, cut, and just put 2 microfarad here. Now this 2 microfarad and 3 microfarad, the effective or equivalent capacitance becomes 2 plus 3, and that is, my dear, 5. So 5 is the answer for this one. Everyone got this? Yes or no? No or yes? Huh? Got response from boys. Now girls have disappeared. So I don't get a response from both the parties. Anyways, my bad luck. That takes me to the next question, and this is the next question, my dear friends. Question number 12. I'm just randomly starting number from 11. You have to find the effective capacitance. Remember, between A and B, you must remember where the point is. Point is A is here, B is here. So I always make a tail like this so that I remember between where to where I have to calculate the effective or equivalent capacitance. You have 2 minutes to get me the answer. So how are you going to do this?
Five, sir.
Yes. This 6 and this 6, as you can see, are in series. 6 and 6 are in series. You can replace this 6 and 6 and put 3 microfarad. 6 and 6 in series. It will be 3 microfarad. Now you look at this 3 and this 3. These 3 and 3 will be in parallel. 3 and 3 in parallel. That means it becomes 6 again. So it becomes 6 again. Ting, ting, ting. Everything on this side disappears. Everything disappears from here. Now again you look at this 6 and this 6. They are again in series. So once they are in series, then they are in parallel. I call it series, parallel, series, parallel. First it was series, then parallel, then series, then parallel. 6 and 6 in series will again get you 2. Will again get 6 and 6 in series will give you 3 again. Now you look at this 3 and look at this 2. This 3 and 2 are in parallel. So the answer becomes 5 microfarad. Do we understand this?
Yes, sir.
The first two 6 are in series. Then that 6 and 6 in series becomes 3. 3 and 3 are in parallel. 3 and 3 are in parallel becomes 6. 6 and 6 are in series, it again becomes 3. 3 and 2 are in parallel, it becomes 5. So we are doing the series parallel combination. We will continue it in the next class. We'll do more questions and try to solve them. Take care, and I hope everyone has understood this. Yes or no? I'll
Yes,
see you in the
sir.
next class tomorrow. Take care. God bless all of you.